आवाज आ रही है। Okay, so hello everyone. I hope my voice is clear. My voice is clear. I'm audible clearly and my video is clear. Just check. Okay, yes. Good afternoon, Anish. Good afternoon, Radha Raman. Good afternoon. Okay, so let's start our session. Okay, yes, yes. Thank you, Anish. So let me introduce myself. This is Sagar Jha, your physics educator on Unacademy. I welcome you all to my class. Okay, so as far as my education is concerned, I have completed my M.Sc in physics from IIT Jodhpur, and I've been teaching students like you for more than 6 years. Okay, you can use my code on Unacademy platform, this code, or else you can use my code SIR SJ. You can use this code to unlock my free classes on Unacademy. And if you buy any subscription over there, if you use this code to buy the subscription, you'll get a 10% discount on it. Okay, so don't forget this code, and let us start today's session. So what will we study today? The topic of discussion for today's session would be dimensions and dimensional analysis. So we are going to be talking about this dimension part, which is the part of your first chapter, units and measurement, of your 11th standard textbook or 11th standard physics. Okay, so the concepts which we are going to talk about today is dimensions, dimensional formula, and dimensional equation. And also on my Unacademy platform, I am having special classes which are free of cost, daily 7 p.m. to 8 p.m. You will find me on Unacademy daily 7 p.m. to 8 p.m. My special classes will be there. You can attend it freely. You just have to use my code. And this is for class 11th. For class 12th, I'll be there at from 8:30 p.m. to 9:30 p.m. Okay, so let us start today's topic. that is dimensional analysis. So we'll just see that why do we use these dimensions and why do we talk about dimensions in physics of the physical quantities. Okay, see, as we all know that there are 7 fundamental quantities listed by SI system of unit, and those quantities are length, mass, time, temperature, or you can say thermodynamic temperature, thermodynamic temperature, then we have amount of substance, electric current, amount of substance, and finally luminous intensity. So these are the 7 fundamental, or you can say base quantities given by SI system of units. Okay, apart from these quantities, whatever physical quantities that we have in physics, all are derived quantities. That means all those quantities depend on this length, mass, time, temperature, current, amount of substance, and luminous intensity. And we also know that we actually have SI units of all these quantities. Now, in SI system, the units of these quantities have been defined. Length, unit of length is meter, unit of mass is kg, unit of time is second, unit of thermodynamic temperature is Kelvin, electric current ampere, amount of substance it is mole, and luminous intensity it is candela. Okay, all these quantities that we have, these are fundamental quantities or base quantities. Apart from that, whatever quantities that we have, they are derived quantities. So, you know, using dimensions, we would just try to find out that a particular derived quantity basically depends, that we know that it depends on all these fundamental quantities. But how these derived quantities depend on these fundamental quantities, that will have an idea of that by using these dimensions. So finding dimensions means finding out how these derived quantities depend on these fundamental quantities. Okay, so let us start. And you know, in dimensions, what we'll do is that we will represent length as capital L, mass as capital M, okay, time as capital T. For thermodynamic temperature, we will use capital K. For electric current, sometimes we use capital A, or in some books, you know, they use capital I. Okay. Sir, one chapter of class 11 is units and dimension. Yes, Anish, it's units and dimension only, first chapter. Units and measurement, yeah, right. Dimensions and dimension analysis is the part of units and measurement only. Okay. Okay. Amount of substance we use MOL, mole, and for luminous intensity we use candela. So see, these are the symbols that we are going to use in dimensions for length, mass, time, and all these quantities. Okay. Now let's start. Let's talk about a derived quantity. First derived quantity that I'm going to discuss is speed. Now just tell me, what is the formula for speed? Speed is a derived quantity. It is not a fundamental quantity, not listed in it. So it must be depending on the fundamental quantity. Now just tell me, what is the formula for speed? Formula for speed is distance divided by time. Okay. Now distance in a sense is length only. We have just given it a different name, right? So suppose I measure a distance, that means I'm measuring length only. So actually if I see over here, so distance is a kind of length only. So I can just write it in terms of dimension. Since we are discussing dimension, it is length. So here I can see that speed depends on 2 fundamental quantities, length and time. Speed depends on length and time. So let me just write capital L for length and capital T for time. And I can write it like this: length, see, Power of time is 1, so if it goes in numerator it will become -1. So L1 minus 1. So this is the speed. So here you can say that speed depends on length and time, and length, power of length is 1 and power of time is -1. Now let's talk about acceleration, or you can say velocity. For velocity also you will get the same thing. You can just derive it, because see, velocity is nothing but displacement upon time. And if you consider these quantities, displacement is a kind of length only. Okay, it's a vector quantity, understood, but as far as its magnitude is concerned, it's a kind of length only. So for velocity also you will get the same thing. It depends on power of length, 1 power of length and -1 power of time. Now if I talk about acceleration, just remember this: speed, velocity. Now let's talk about acceleration. What is acceleration? Acceleration is change in velocity upon time. Now velocity, change in velocity is also velocity, because change in velocity is final velocity minus initial velocity. Final velocity minus initial velocity will give you velocity only. See, we are concerned about quantity, so you will have velocity only. Change in velocity is simply velocity upon time. Now we know that velocity is displacement upon time. Displacement is a kind of length, so it will be length upon time, and already you have one time over here, so it will become time square. Yes, right, correct, yeah, right. So now length I can write L, time I can write T, and it is T square. So now it will become L1 T raised to -2. If it goes in numerator it will be -2. Now again, see, you can see over here that velocity, speed and acceleration all depend on length and time only, but they don't depend on length and time in the same way. Acceleration depends on the power 1 of length and power -2 of length. So that is the difference over here. Okay, you're getting it? Now if we consider about, let's talk about volume. What is the formula for volume? Tell me, what is the formula for volume? Volume, it is length into breadth into height, or if I consider a cube, it will be length cube. See, length, breadth and height all are fundamentally length only. So I can just write length into length into length, or simply length cube, or I can write L cube. So your volume depends on one fundamental quantity, and that is length only, right? But it depends on power 3 of length. Just try to see the powers. Okay, length depends on power 3 of your, just a second, yeah, Amit, have you come now or what? See, I'm just trying to make it clear that all these fundamental physical quantities depend on some fundamental quantities. We have these fundamental quantities, right, Amit? Length, mass, time, temperature. The formula for volume is length into breadth into height. See, formula for volume is length into breadth into height. Now when you measure breadth, see, breadth is a kind of length only, right? Height is a kind of length only. So length into length into length will become length cube. Okay, so volume depends on length cube, or power 3 of length. So this was all about volume. Now let's talk about density. Topic is dimensions and dimension analysis. Amit, dimensions and dimension analysis. We're talking about dimension. Okay, try to understand this. What is the formula for density? Let me just be clear with it. What is the formula for density? Density, it is mass upon volume, right? For mass, I just told you that we'll use the this letter capital M. So I'll just write capital M over there. For volume, I know it is L cube, length cube, so it will be L3. So density will become M L raised to -3, because it goes in the numerator and power of M is 1. So now here you can see that density depends on सर आप कहाँ के हैं? अमित, आई एम फ्रॉम मुंबई, महाराष्ट्र only, yeah, Mumbai, capital of Maharashtra. Okay, yeah. So the formula for density depends on mass and length. One power is for mass and for length power is -3. Okay, now see, you know, whatever these powers are telling you that whatever these quantities are, how they depend on these physical quantities or fundamental quantities. So density depends on mass, but power is 1, length power is -3. So whatever powers that we have over here, these powers are nothing but dimensions. These powers are called dimensions. Okay, so I can say that the dimension of speed is 1 and -1. 1 in length, -1 in time. Dimension of velocity is 1 in length, -1 in time. Acceleration 1 in length, -2 in time. What is the dimension of volume? It is 3 in length. Dimension of density 1 in mass and -3 in length. So these powers that you can see, they are nothing but dimensions. Okay, and you have to, you know, tell us that how these quantities depend on all these fundamental quantities. So let us take an example of this speed. If someone asks what is the dimension of speed, so while writing the dimension, you just use this square brackets. So if you're using this square bracket, that means we are clear that you are talking about dimensions. Okay, and see, dimension means you have to tell us that on which powers all fundamental quantities, on which powers of fundamental quantities this speed depends. So we can clearly see that it depends on length and time, and powers are 1 and -1. So I'll just write length power 1, time -1. And it doesn't depend on mass, so I will write mass power 0. And also you will have to, you know, write all these quantities also. Neeraj, it is dimension analysis. That is a subtopic of your first chapter, 11th standard. Okay, now apart from length, mass and time, we have thermodynamic temperature, for which we are going to use this K, letter K, current, amount of substance and luminous intensity. So you have to mention all that also. That is temperature, for temperature it is K, but speed does not depend on temperature, so power will be 0. Speed does not depend on current also, so power of current will also be 0. Speed does not depend on amount of substance and luminous intensity, so powers of them will also be 0. Okay, so this is how you represent basically a dimensions. So I will write the dimension of speed is 0 in mass, 1 in length, -1 in time, and 0, 0, 0 and 0 in all these fundamental quantities. So it can clearly tell you that speed does not depend on mass or these quantities, because powers are 0. Speed depends on length and power is 1, and time power is -1. Now generally what happens is that, you know, when we are actually studying physics and we are just starting with motion, that means mechanics. In mechanics you will never find all these quantities. You will never see temperature or this what you can say, current or something like this. When we just study all those things, that when we study heat, when we study current, when we study charges, then these quantities will, you know, enter our study. So normally what we do is that we just drop all these quantities. We never write all these quantities unless they enter afterwards. So, you know, for 4 to 5 chapters you will just use these 3 quantities: mass, length and time. You can see clearly that only mass, length and time you can see everywhere. Mass, length and time, mass, length and time. So for a larger part, you know, at the start for some chapters you will never see these quantities. So if someone asks you to write the dimensions, you just only have to write the dimension of mass, length and time. Okay, so for speed I'll just write dimensions of speed are 0, L1, T minus 1. 0, 1 and -1. 0 in mass, 1 in length and -1 in time. Now just tell me what is the dimension of velocity. So here we have dimension of velocity to be equal to, see, L1 t minus 1, it depends on length and time only. So mass will be 0, m0 L1 t minus 1. Dimensionally speed and velocity are equal, they have the same dimensions. Okay, if you have any question you can ask, okay, if you have any doubt. Then let's talk about acceleration. Here you can see what are the dimensions of acceleration. The dimensions of acceleration are, just a second, I don't know whether it is visible or not. Yes, m0 L1, here you can see, and t minus 2. Sejal, actually, you know, I'm not allowed to speak in Marathi or Hindi, any language, because actually I'm an English educator. Okay, so I'm just authorized to speak in English only, that is the problem. Okay, if you have any doubt you can surely ask, no problem, okay, in the chat box. Sorry for that. Okay, here you have speed, velocity and acceleration, dimensions of all these quantities. And again, if someone asks you what is the dimension of density, and dimensions of density are, just write density, and dimensions are m1, here you can see m1 L minus 3 and t0, because it doesn't depend on time, right? Okay, thank you Sejal, thank you. So this is density, the dimension of density are m1 L minus 3 and t0. Now I just told you that these are the dimensions. Suppose I have just written that dimensions of density is m0, sorry, m0, not m0, it is m1 L minus 3 and t0. So I just told you that these powers are the dimensions, 1, minus 3 and 0. These are the dimensions, 1, minus 3 and 0. These are the dimensions. So powers are the dimensions. And you have to also mention that 1 in mass, minus 3 in length and 0 in time. Now, when we also write the, you know, quantities on which the dimensions on which this your quantity depends, okay, along with dimensions, when we mention the quantities also, then it is called as dimensional formula. For example, if I write m1 L3 and t0, so from here it is clear that dimensions are 1, minus 3 and 0, and also it is clear that 1 in mass, minus 3 in length and 0 in time. So it is telling, this expression is telling you about the quantities also on which density depends. So this entire expression that you are saying is nothing but dimensional formula. This is what we call dimensional formula. The powers are called dimensions, okay, and powers are called dimensions, and if you write this MLT everything in square bracket, this entire expression is called as dimensional formula. And if you equate dimensional formula with the quantity of which you are calculating the dimension, for example, you are calculating this dimension of density. So I'm just writing dimensional formula of density over here, it will be more clear. So if you equate density with this dimensional formula, then it will become dimensional equation. For example, if I write density is equal to m1 L minus 3 and t0, then this entire equation that you are saying in front of you, this is what we call dimensional equation, because now we have equation, dimensional equation of density. Similarly, you can have, you know, dimensions of other quantities also. So now we will just try to find out dimensions or dimension formula or dimensional equation of some other physical quantities. And whatever quantities that I am just telling you, you should remember the dimensions of these quantities. It would be easy for you only when you study physics and if you are asked to find the dimensions. So dimension of speed is m0 l1 t1. Here you can see velocity m0 l1 t minus 1, acceleration m0 l1 t minus. Okay. So there are daily live lectures of physics. Well, I'll be taking live lecture of physics on Monday, Wednesday and Friday, Saturday. For Monday and Wednesday it will be for class 11, and for Friday and Saturday it will be for class 12. Okay. And also I'll be taking daily lectures. I just told you daily I'll be having special class on Unacademy platform. Okay, so you can just download Unacademy learners app, and there I'll be there daily 7 p.m. to 8 p.m. for class 11 and 8:30 to 9:30 p.m. for class 12. And I won't be on Sunday. Okay, except Sundays. Except Sundays, I will be there daily from 7 p.m. to 8 p.m. Okay. Okay, let's get back to the topic. So now just remember all this: speed, velocity, acceleration and density as well. Dimensions of density. Here we have dimension of volume. Okay, just tell me the dimension of volume. The dimension of volume, it is L3, right? So we can write dimension of volume to be M0, L3 and T0, because it doesn't depend on mass and time. It only depends on length. So M0, L3, T. Okay. Yeah. Now let us calculate dimensions of some more physical quantities, and let's see. So we'll calculate dimensions of force right now. Force. What is force? Let me just say it. Force is equal to mass into acceleration. Okay, force is equal to mass into acceleration. Now what is acceleration? We just saw. See, you just keep on breaking it until it, all the quantities become fundamental quantities. We know that acceleration is not a fundamental quantity, it's a derived quantity. So again, just break it. You have to keep on breaking it until we reach that stage where all the quantities are fundamental quantities only. Acceleration is not a fundamental quantity, it's a derived. And we know that acceleration is change in velocity upon time. And change in velocity is actually velocity only, so it will be velocity upon time. Okay. Now, mass into what is velocity? Velocity again is displacement upon time, and we know that displacement is a kind of length, so it will be length upon time square, because time is already there. Velocity is length upon time, so it will become mass length upon time square. And mass we denote as capital M, for length capital L, and for time capital T square. So it will be M1 L1 and T power 2, and finally we can write it as M1 L1 and T power minus 2 if it goes in numerator. So these are the dimensions of force. The dimension of force are M1 L1 T minus 2, and here we have written the dimensional equation of it. Okay, so we calculated the dimension of force. Now any other quantity? Okay, work done. Work done. What is the formula for work done? Work done is force into displacement, right? Now we know the dimension of force. Okay, it is simply M1 L1 T minus 2. So dimensions of work done will be equal to dimension of force multiplied by dimensions of displacement. X is displacement. So we already know the dimensions of force as M1 L1 and T minus 2. Okay, and since displacement is a kind of length only, so it will be L1. It will become M1 L1 and L1, that will be L2 and T minus. So these are the dimensions of work done. Similarly, we can find the dimensions of other quantities as well. Yes, right, yet. Okay, so let me just write quantities over here in this column, and then we will have their units or dimensions, sorry, dimensions. Then we will have their SI units based on that. Quantities, dimensions, SI units. Let's start. Okay, one more thing I just wanted to write, their formula. Quantities, then formula, then dimensions, and then SI units. Okay, let's start. A very simple one, area. What is the formula for area? It is length into breadth. Okay, and if we consider a square, it will be side square. So finally length and breadth both are length only, so it will be length square. So dimensions will become M0, L2 and T0, because it doesn't depend on mass or time, right? Yeah. Now L2 is SI unit. See, it is length power 2. Now length, we know that it is unit of length is meter, so we can clearly write it to be meter square. Okay, so we can easily get the unit if we know the dimensions. The dimensions, we know it is L2, length power 2, so unit of length is meter, so it will be meter square. Okay, now let's move on to volume. What is the formula for volume? This we have already seen, it is L3, so it would be M0, L3 and T0. Now length power 3, so it will be meter cube. SI unit of volume is meter cube. Okay, now area, volume, then we will have let's say speed. Formula for speed is distance upon time, and we have already calculated it. Distance upon time is, distance is length time minus 1. What will the formula for it? Meter per second, right? Then velocity, we will have same thing. See, velocity is displacement upon time. Displacement is a kind of length only, so you will have same dimensions as M0, L1, T minus 1 and same unit meter per second. Okay. Then what else? Velocity. Then we can have acceleration. You know, acceleration formula is change in velocity upon time. We have already calculated the dimensions of acceleration. It is M0, L1, T minus 2. Okay, now just see M0, L1, T minus 2. How to get the units from dimensions that you just see over here? How to get the units from dimension? It is L power 1 and T power minus 2, acceleration, right? L means length, the unit of length is meter and power will be 1. Time, the unit of length is second, sorry, the unit of time is second and power minus 2. So you can simply write the unit of acceleration to be meter per second power minus, or second power minus 2 can be written as meter per second square, because you know this simply means meter upon second square, because in the denominator it is second square, and if you bring it in the numerator it will become s power minus 2. Time and mass is not there. See, for time, see, you can just write M0, L0, T1 simply, because time is time power 1. For mass, dimensions are simple, M1, L0, T0, right? That is simple, don't need to discuss that, it's quite easy, right? So simply you can write this as, so by using dimension you can get the unit also. Okay, now so meter second minus 2 is nothing but meter per second square. Now let's talk about force, dimensions of force. What are the dimension of force? Let us first write its formula. F is equal to m into, okay, just a second. Okay, so here we are. Force is equal to mass into acceleration, and we have just calculated a dimension. Here you can see force m1 l1 t minus 2. Okay, m1 l1 t minus 2. Now let's try to get the equation, or the SI unit, using this dimensions. See, the force is m1 l1 t minus 2. Okay, so now m is mass and the SI unit for mass is kg, kg power 1. Length means meter, okay, SI unit is meter, and for time it is second. So you can write SI unit of force to be kg meter second power minus 2, and you know this can be written as kg meter per second square. Okay, now you must be wondering that sir, this unit for force that we have heard is that Newton, right? You're just telling that kg meter per second square. You must have heard the unit for SI unit for force is Newton. You know what, that this kg meter per second square, or kg meter second minus 2, this in short is called as Newton. Okay, this part is nothing but Newton. It is simply called Newton. So Newton means kg meter per second square, or kg meter s power minus 2. So this in short is called as Newton. Okay, this in short is called as Newton. That's why we say that the unit, SI unit for force is Newton. But the meaning of Newton is this, kg meter per second square. I hope you are getting it. Okay, so this is what your unit Newton means. Okay, Newton is not a new unit, I would say. Newton is simply kg meter per second square, right? Okay, now let's talk about momentum. What is the formula for momentum? For momentum it is momentum mass into velocity. Okay, now let us calculate the dimension. See, it is easy to calculate the dimensions of momentum because we already know the dimension of velocity. Just multiply mass and velocity, you will get the dimension of momentum. Okay, see, mass into velocity. Mass we know it is m1, and velocity here it is yeah, this is the dimension of velocity, m0 l1 t minus 1. So what will it become? m1 1 plus 0 and l1 t minus 1. So these are the dimensions of momentum, m1 l1 and t minus 1. Okay, now let's talk about its unit. Okay, mass it would be kg, length it would be meter, and time inverse, so it would be kg meter second inverse, or you can write it as kg meter per second. Okay, so kg meter per second is your SI unit of momentum, right? Here, shall we move ahead? Okay, okay, not much time is remaining, come on. Okay, so some more dimensions and then we'll end the session for today's. Yeah, okay, thank you. Let us see some more quantities. Work done we just calculated, right? Let's see kinetic energy. Kinetic energy, potential energy, and we missed density. We will calculate the dimensions of these quantities and then we'll just wind up. Work done also. work done also. Let us do it fast. Kinetic energy. What is the formula for kinetic energy? Come on, fast. Half mv square. See, the number doesn't have any dimension. Just leave it. Mass. Mass is m1, and velocity. Dimensions of velocity are m0, l1, t minus 1. Okay. Mass into velocity. But it is velocity square, so it will become m1. Just square everything. It will be m0, l2, t minus 2. Okay. Now it will become m0, m1, l2, t minus 2. The dimensions of kinetic energy are m1, l2, t minus 2. Okay. Similarly, for it is m1, l2, t minus 2. Now you see, if you calculate, if you just try to find the unit, SI unit of kinetic energy. Let us just try to find the SI unit of kinetic energy. What will it be? For mass it is kg, kg power 1. For length it is meter, and meter square because L square, and time s minus 2. Or you can write it as kg meter square per second square. Now I'll just tell you, this entire thing that you can see over here, this is the unit of kinetic energy that I told you. But this entire thing is actually called as joule, in short, joule. So if someone says you that yes, the SI unit of kinetic energy is joule, it is correct, because joule is nothing but kg meter square per second square. In short, we call this as joule. And if you calculate, you just try it on your own. If you calculate potential energy, formula is mass into acceleration into height. Mass into acceleration into height. You will get the same dimensions, m1, l2, t. Okay. So the SI unit of potential energy is also same, and in short it is joule. If you calculate work done, we have just calculated work done over here, force into displacement, and we got the same dimension as m1, l2, minus 2 with the same unit as. Okay. So for work done, potential energy and kinetic energy, or any kind of energy, you have same dimensions and same unit as joule, and joule is nothing but kg meter square per second square, right? Density you can calculate. We just calculated density is mass upon volume, and we had calculated it was m1 l minus 3 and 0, and unit you will get kg per meter cube. Okay, so I hope you would have understood it. So let us just end the session. So your class on Unacademy batch, we have started with all these batches: bridge courses for maths, bridge courses for physics, chemistry, and biology. So there is also full syllabus for physics, chemistry, and maths. On Unacademy platform, I am starting the full syllabus for physics 11th standard from 12th of July, and for 12th I am starting a bridge course from today itself from 4 p.m. Okay, so these are the courses that we'll have on Unacademy. You can just go over there and subscribe for it, and if you're subscribing it, please don't forget to use the code SIR, 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 SJ. Okay, by using this code you will get 10% discount on any subscription. Okay, so also you'll have maths and science full syllabus batches that we are starting. Here you can see that I'm starting, and my lectures will be from on Monday, Wednesday, and Friday. Okay, whatever my plus classes will be there, it will be from Monday, on Wednesday, Wednesday, and Friday from 5:15 p.m. to 6:15 p.m. 5:15 p.m. 6:15. The entire course will be there. All full 11th standard we will cover, and it will be from 5:15 p.m. to 6 p.m. from 12th of July till December. Till December we will end the entire syllabus of 11th standard. On Unacademy, you can get the classes in Marathi, Hindi and English of your own choice, whatever language that you prefer, right? So, and also, you know, there's a new feature. There will be free test series every Saturday and Sunday. You can avail this thing also on the platform. You just have to, what you have to do is that just go on Google Play and download Unacademy Learners app. Okay, Unacademy Learners app, and if code is asked, you can just use Sir SJ, this code, okay, to attend all the free classes. And if you buy any subscription, you will get 10% discount on it if you use this code Sir SJ. Okay, so use my code as I had just told you, Sir SJ, and get all the offers that I just mentioned, 10% discount on any subscription. So these plans are there, affordable, at affordable prices. You can have plans for 28 months, 18 months, 12 months, 6 months, 3 months, and for also 1 month, which is starting at 2000 rupees per month. Okay, and you can choose different payment method from here. You can pay in installments also, and zero cost EMI is also available. Thank you very much for today's session. Thanks a lot. Yeah, Sir SJ. Thank you.